Welcome to a presentation of project Sorevision. Although the images that you see on the right are kind of unpleasant, mouth sores are quite a common occurrence. Mouth sores can happen inside the mouth, on the gums, on the lips, around the lips, or totally outside the mouth. What most people don't realize is the fact that mouth sores come in two different varieties. The first kind, which is commonly referred to as the cold sore, is highly contagious and it can be passed on from person to person with just skin to skin contact. The other kind of mouth sore, which is referred to as the canker sore, is luckily not contagious. We wanted to provide a solution for users to be able to find out what kind of mouth sore they currently have. So, Sorevision is an HTML5 mobile responsive web app that can aid a person in identifying the kind of mouth sore. The use case is pretty straightforward. The person simply takes a picture, presents it to Sorevision, and Sorevision uses a pre-trained deep learning model to identify, classify, and provide immediate feedback with a certain degree of confidence. The application architecture is pretty straightforward. Users simply open up a standard browser and they bring up the application. And once the application is available on the browser, they upload an image. The web server picks up the image, sends it to the app server. The app server in turn sends it to Clarify, and Clarify in turn looks up this image against a pre-trained model, comes up with the class information, provides it to the app server, which in turn provides it to the web server, which in turn is presented to the user on the browser. The use case is similar for both Clarify as well as retrained inception model. So the technical approach is pretty straightforward. The web UI is built using HTML5 and jQuery. The HTTP servers, which are receiving the images, are built with standard Java-based HTTP server and a Python-based HTTP server. A visual model is trained using Clarify API. We also retrained the last layer of an inception model, and we are using that to kind of figure out how it would compare with Clarify. And we also tried to use Spark MLlib to see how MLlib would perform against classifying these images. The dataset included about 75 training images picked up from Google Images. To see how it performed, we tested with 6 different images. The 6 different images were classified using 3 different means. The first one was a human dentist. The second one was using Clarify API, and the third one was to use a retrained inception model. If you look at it, the dentist obviously was able to classify this 100% of the time with 100% confidence. The inception model and the Clarify model both performed really well, although the Clarify model performed just a little bit better. So now let's take a look at how the app really works. We have 2 browser windows here. The first one is using the inception model, and the second one is using the Clarify model. The inception model is listening on port 8080, while the Clarify model is listening on port 8081. So we can provide that with the standard image that we have in our library, and then we can just let it predict, and it comes back with a score of 89.88% confident that this is a cold sore. Let's see how Clarify does with the same image. So if you look at the same image and we predict that, Clarify comes back with an 86.59% chance that it is a cold sore. If we were to pick a different image, in this case, let's pick an image that actually has a little bit of a uniqueness to it. So let's see how inception model does on this one. It comes back, it's a little confused. It comes back with a 59% confidence score, but it's a canker sore. Let's see how Clarify does with the same image. comes back with a 93.37% that this is a cold sore. This, in fact, is a cold sore, which is actually at the very last stage of its journey. Anyway, thank you very much for listening to my presentation. If you have any questions, please let me know.